5177-1. The ratio of an airplane's true airspeed to the speed of sound in the same atmospheric conditions is A. Equivalent airspeed. B. Transonic airflow. C. Mach number. The correct answer is C. The Mach number is a dimensionless quantity that represents the ratio of the speed of an object, in this case, an airplane, to the local speed of sound. It is named after the Austrian physicist and philosopher Ernst Mach. Mach number is used to describe the speed of an aircraft relative to the speed of sound. For example, Mach 1 indicates that the aircraft is traveling at the speed of sound. Mach 0.5 means it is traveling at half the speed of sound, and so on. The Mach number is an important parameter in aviation, particularly for high-speed and supersonic flight. 5177-2. What could be one result of exceeding critical Mach number? A. Propeller stall. B. Reduction in drag. C. Aircraft control difficulties. The correct answer is C. The critical Mach number is the speed at which an aircraft's airflow over certain areas of the aircraft, such as wings or control surfaces, reaches or exceeds the speed of sound. When an aircraft exceeds its critical Mach number, it enters the transonic range, where airflow behavior changes significantly. Exceeding the critical Mach number can lead to a phenomenon known as transonic airflow, which can have several effects on aircraft performance. These effects may include shockwave formation, increased drag, changes in control effectiveness, and potential aircraft control difficulties. 5016-1. 14 CFR Part 1 defines VLE as A. Maximum landing gear extended speed. B. Maximum landing gear operating speed. C. Maximum leading edge flaps extended speed. The correct answer is A. VLE is the maximum landing gear extended speed. 5016-4. Newer airplanes have a design maneuvering speed that can generally be calculated as follows. A. 1.2 vs0. B. 1.7 vs0. C. Half the stall speed. The correct answer is B. For all modern designs, the maximum speed at which a hero plane may stall safely is now known. All recently designed aircraft must have this speed entered in the AFM/POH. It is known as the Design Maneuvering Speed, NV. This speed for older general aviation aircraft is roughly 1.7 times the typical stalling speed. An older aircraft, for instance, cannot stall at 102 knots. 60 knots multiplied by 1.7 is 102 knots. A plane that normally stalls at 60 knots experiences a load factor equal to the square of the speed increase, or 2.89 gs. 7 times 1.7 is equal to 2 bag gs when it stalls at 102 miles per hour. 5740. To determine pressure altitude prior to takeoff, the altimeter should be set to A. The current altimeter setting. B. 29.92-inch Hg and the altimeter indication noted. C. The field elevation and the pressure reading in the altimeter setting window noted. The correct answer is B. Pressure altitude is the altitude indicated by an altimeter set to 29.92 inches of mercury, Hg. It is a measure of the weight of the atmosphere above the aircraft and is not affected by the aircraft's altitude above sea level. To determine pressure altitude prior to takeoff, the altimeter should be set to 29.92 inches of Hg and the altimeter indication noted. This will give the pilot the actual altitude of the aircraft above sea level, which is important for calculating takeoff performance and other factors. The other answer choices are incorrect. Setting the altimeter to the current altimeter setting will give the pilot the altitude of the aircraft above the local pressure setting, which is not the same as pressure altitude. Setting the altimeter to the field elevation and the pressure reading in the altimeter setting window noted will give the pilot the field elevation, which is also not the same as pressure altitude.